Okay, I think it's time to start. If you don't know me, my name is Mateusz Pusz. I'm the member of the C++ committee. I'm also the C++ trainer, consultant, and a principal engineer at EPAM Systems. We are meeting today to talk about my experience with CMake and Conan and basically handling of packages in the open source world. I don't know if you attended my last talk or seen this online. Nearly exactly 3 years ago. It was actually, I think, on the 7th or 8th of May 2018. I provided a talk about the Git CMake Conan, where I was discussing how to ship and reuse our C++ projects. Today, I'm going to provide you some update, what has changed in this meantime. So what really has changed? CMake turned from 3.11 to 3.20, and you had 64 major and minor releases. Conan was updated from version 1.3 to 1.36, and you had 123 releases of this product. And there's also me. I'm 3 years older. I really don't know how to count my releases, minor and major ones. Should I count them in years, months, weeks, days, or maybe in those aha moments that basically I had working on the subject, or maybe by the number of trainings I gave on Conan and CMake in the meantime. I really don't know, but it was 3 years ago. I'm more experienced right now, and this is why I decided to provide this talk to you. First, let's start to talk about CMake. If you didn't see this talk of Daniel Pfeiffer, you should really go and see it. It was the first one talking about the modern CMake. It was one of the best ones, my favorite ones in this subject. During this talk, one of the things that Daniel shared with us is that variables are so legacy CMake. They shouldn't be used in the modern software, in the modern CMake approach. So I would claim that we shouldn't introduce custom CMake variables unless we really need to. Custom variables in CMake are error-prone, often introduce a lot of noise to our code, and complicate maintenance. During my trainings on CMake, my students ask me to talk about targets, installation, and other stuff. But when I want to describe how variables work, they don't want to listen. They say, well, we are experienced engineers, we know plenty of different languages, we know how variables work. But actually, it is not that easy with CMake. And this is the biggest problem. We ignore the fact that such a thing can be really not trivial. And this is why we have later on problems with the maintenance of the software. So maybe let's try our gut feeling about CMake, and let's run several polls. Actually, I have 10 really short polls for you, so you can try out how do you feel about the code I'm presenting. So in this code, we are setting a variable foo with the value 0, and you want to print it in these 3 ways, or create a branch in the same 3 ways. And the question is, what will be printed on the screen during the configuration phase? I will give you like 15 seconds for each poll because we don't want to spend too much time. It's pretty simple exercise, so let's find out how we do here. You should see a poll in Zoom already, and please answer which one of those will be printed. Okay, it's 30 seconds nearly, so I will give you a bit more time. And okay, 30 seconds, I'm ending the poll because we have to be on time. I don't know actually if you will be able to see this in Zoom, because maybe it does remove it, but I will share the results. We actually had 36 percent of people said that they don't know what's the answer, and only 7% answered correctly, because the correct answer is this one. So only 7 answered from this great audience in CppNow actually was right here. So let's try a bit different. Right now we are using setting the value on rather than 1. And let's try again. What will be printed on the screen? Okay, 30 seconds gone. Again, 35% of people decided to choose the I don't know answer, and this time 24% of people were correct. What was wrong here, or what was the correct case here? Okay, so 2 more. First, we are going to set ABC as full, and check what will be printed on the screen this time. Okay, 30 seconds is gone. The answer is number 3. And actually no one selected it. 0 people, actually 0%. No, even one voice was not provided for this answer. As you can see, CMake is really misleading. So if you think that you know about variables, probably that's not the case for CMake. Maybe I'll just, if we didn't know exactly what is the answer here, maybe I'll just show the next poll, but I will not run it because we are tight on time. But I think I proved my point. That if you actually define the variable ABC with ABC value, the output will be even different. This will be full ABC number 1 and number 3. So, as you can see, the logic in CMake is not that easy. Basically, if you have quoted or unquoted constants with values on, yes, true, y, then the branch will be taken true case. If you have other, of, no, false, n, ignore, no found, or maybe minus no found, then will be false. If you list a number, it will be converted with bool logic according to C rules. And otherwise, it's treated as a variable name. So if I will try to go back to the previous slide, I don't know why I cannot. So in this case, this variable is treated as a variable name, and here is just a text. So these two are different. In case of branches, this will be treated as variable. And this is called fall-through case. And the fall-through case works as follows. The expression is either an unquoted variable name, and if it is undefined variable, then it's false. If it matches false constants from the previous slides, it's false. Otherwise, it's true, always true. It doesn't have to match true constants. And in case of quoted string, the quoted string that doesn't match any of the defined true constants always evaluates to false. So the default is different. It was always true in the previous case. This case is always false. And it was even different before CMake 3.1. Okay, I have one more poll for you. Another example, when we are using variables and cache variables with the same name. Let's try this time what can be printed on the screen, and I mean during the first run of CMake. In the meantime, I see some enthusiasm on chat about this poll and quiz. So sometimes it's good to learn what we don't know, right? I always find it in C++. Okay, so here are the answers. In the first run, it will be empty, on, off, on. So the answer 2. So 30% were correct, 30% were wrong, and 30% said that basically they don't know. Let's try one more, only poll this time because we are tight on time. What will be printed on the second run of the same code? Oh, sorry, I spoiled it. Too fast. Okay, I'm ending the poll. And during the second run, we'll see off, on. So the answer 1, and 19% of you were correct. And the most people thought that it will be on, off, on, which is not the case here. And there are of course some variations here, because instead of using set, you can use options. And options, they look like a shortcut of the previous case, but actually have different logics in the CMake also. During the first run, we'll have empty, on. During the next runs, we'll have exactly the same. And actually, when you change the version of the CMake from 3.19 to 3.12, you'll have even different behavior. So as you can see, it's not easy to work with variables in CMake. Just to maybe clarify what was happening on the previous poll. Basically, CMake treats normal and cache variables as two separate sets. If you have two variables, one being normal, one being cache, with the same name, they are stored in different sets, and the normal one has higher priority, and the cache one is overwritten, hidden below, let's say. So normal variables take precedence over cache variables. So if you take the value of it, it will take the normal value if basically rather than cache one, if normal is provided. The exception is when you set a new variable. So if the cache variable didn't exist, then this one will be the best one. Or it existed before but had so-called undefined type, because the cache variable can have an undefined type if you will not specify one, or if you will use force or internal option during setting of this cache variable. And as you've seen in CMake 3.13, option, basically behavior of the option changed. Before, it will behave the same as set, but starting from CMake 3.13, basically normal variable, if it already exists, the option will not be set at all. The command does nothing. So this is why I always say that CMake is a great build system generator, and it really is. This is my opinion and many other experts in the industry, but it's a really general purpose scripting language. As you can see, things that should be easy that we seem to ignore because they are easy. As I said, most of my students don't want to listen to me before the poll, because after the poll they are really happy to know the rules of the language. But people don't want to read about it, think that they know about it, and try to play with it in their scripts, and they then have a lot of maintenance issues. I would say that the less CMake, the better. Put to the CMake files only what is really necessary to make the build succeed. Choose alternative if only possible. Use dedicated package managers to handle packages. Use scripting languages like Python or any other if you need some CA-like scripts and you don't using CA engine that's provided already. But if you want to do any scripting, prefer other languages over CMake rather than doing everything in CMake. CMake should not be treated as a general-purpose programming language. Okay, so what has changed in the last 3 years in CMake? First of all, we got C++20 support with CMake 3.12. Now you can specify standard 20 as a feature required for the compilation, and it will be set, and it allows us to provide C++20 libraries, like my physical units library written in C++20 and doing physical units calculations and dimensional analysis. Installation was simplified. Before, in every install command, we had to provide destinations for every kind of things we want to install. Basically, everyone defined it by themselves in their projects. There was no consistency between different projects. And sometimes it's hard to make correct, because sometimes lib is not a correct answer here. Sometimes you may have lib64, for example, on some strange Linux-like operating systems as a correct answer. And you never know. Hardcoding 1 may not be the correct answer for every operating system you would like to install. After CMake 3.14, we should just use GNU install dirs. We're including this, and install command will use defaults provided by this definition, and it knows exactly what operating system you're running on, what are the requirements for the system, and where specific kinds of artifacts should be installed. If you will not install dirs, you will have pretty well defined defaults provided by CMake, but you will end up, for example, with lib everywhere rather than lib64 on CentOS, which should be actually provided one on this operating system. Another issue that was really bothering me for a long time, it was that CMake until CMake 3.15 was providing a default compilation flag like /w3 for MSVC compilers. So if you wanted to change it, you actually couldn't provide another one in the string of options because it was not valid for the compiler. You had to replace the previous one with empty or with correct value and then overwrite with a new value here, which was really bothering. And if you didn't know about this feature, basically you didn't get what you expected. Right now, the default compilation warning flags are not set, the same as for GCC, as for Clang and other compilers. So you can just add your own warning level and everything will be correct and easy to provide. Another really important feature is support for Ninja. CMake had Ninja support for a long time, but starting from CMake 3.17, we got Ninja multi-config. And I consider this the best generator ever for CMake. Basically, Ninja by itself, no matter if you use Ninja or Ninja multi-config, it is the best generator in my opinion. It's very efficient and it has really broad platform support. I use Ninja on Windows, on Ubuntu, on CentOS. It works everywhere. And I don't have to care if I should use some Makefiles generator or Visual Studio generator or maybe Xcode or I don't know, code blocks or whatever. Just use Ninja and you are fine on every operating system. It simplifies workflows, scripts, and actually it is probably the fastest one to execute. 3 years ago, I provided typical CMake workflow. As you can see here, I was assuming that CMake will detect that it's a Makefile generator for GCC. For Visual Studio, I had to provide my own generator. And also, I provided here CMake build and -- target install to install stuff after it's being built and tested. Right? It changed. With CMake 3.15, we got the possibility to invoke the install step directly without going through the build tool. It's even really handy sometimes if you're, for example, installing header-only library. You don't have to even call CMake build. You can just call CMake install and it will copy-paste all of the headers in a proper directory. So it may be faster. Additionally, okay, this is the syntax. So you just call CMake -- install and provide the directory when you want to, where your binaries of CMake are, and they will be installed. So it's again one more layer of being independent from the build tools, from being independent from the underlying build systems. And what's really cool about install is that it has additional options. You can specify a prefix where to install. You can specify strip to strip stuff from the symbols. And of course, for multi-configuration generators, you can specify config, which configuration you want to install, release, or debug. So now, this is the updated workflow after 3 years. I don't care about Makefiles, GCC, or Visual Studio. I don't ask anymore what compiler I'm using. I'm just saying if I want a single configuration generator or multi-configuration generator. In both cases, I'm using Ninja. And I don't care if it's Visual Studio, C-Lion, MSVC compiler, GCC, or Clang. The only difference here is that in single configuration generators, you have to specify CMake build type during configuration phase. If you will not provide it, you end up in so-called unnamed build type. It's not a default. It's not a debug. I've heard that people say if I don't specify to release, it will be a debug build. No, it's not. It's actually separate type of build, some generic one, some unnamed one. Debug and release are different from the one that is not spelled in configuration phase. But then if you specify it during configuration, you don't have to specify it in build and install because there is only one option here. In case of Ninja multi-config, you don't specify the build type during configuration phase because you don't know how it will be built. For example, which combo box will be selected in the IDE. And then you have to provide the configuration for every other steps, build, test, and installation. So this is the difference here. Fortunately, if you want to create a generic script that will work with every generator, you can just provide build types in every step, and CMake will ignore those configs for single configuration generators and will ignore CMake build type for multi-configuration generator. So with such a simple script, you can take any generator and any build type you specify, and it will work correctly. With CMake 3.13, you get an option to specify default CMake generator that should be used in your system. So immediately I put it to bashrc that I'm using. First, it was Ninja. From CMake 3.17, I started to use Ninja multi-config as my default one. And from that point, I don't have to specify it anymore in the command line during configuration phase. Also, in CMake 3.17, we got an option where we can set the default build type. But please note that this works only for multi-config Ninja generator. It will not work for Visual Studio or any other. So CMake default build type is only used for Ninja multi-config, even not for Ninja itself. But if you set those two, then your workflow may look as follows. You don't have to care about generator here because it will be Ninja multi-config by default. You don't have to provide configs here because it will be released by default. But you have to specify it in CTest, at least I think so. That CTest may not benefit from this setting. But I may be wrong. And only if you want to make a debug build, then you have to specify configs debug because they will be different from the default specified in the bash or C or whatever in your environment variables. I see that you have a question from Jeff asking that in our previous workflow with Makefiles, we only do CMake once and then just use make instead of CMake and CTest. Can something similar be done with Ninja? Is there some advantage of keep using CMake command? So yes, you can use actually here Ninja and make if you prefer. But I prefer to be build system agnostic. I don't want to know what's underneath. I don't want to know what are the command lines for it. if you create a bunch of scripts working with CMake, but you will specify that you want to use Ninja or Makefile, and you'll have them in CI and everywhere, and then you find out that there is a new, better generator on the market, you'll have to rewrite everything. You have to learn how to provide those command lines by hand, what are the options, and so on. With CMake wrapper, you don't care. It may be Visual Studio, it may be Makefile, it may be Ninja, and build and install will just work. You don't have to care, basically, what's the syntax in command line for those build tools. I think this is the preferred solution. It's just wraps over the build system, and you don't care what's beneath. One more thing. Before CMake 3.14, it was really hard to find out what are the command lines being called by CMake. What I was doing until then, I was switching from Ninja to Makefile and was using this CMake verbose Makefile on variable in CMake to force Makefile generator to provide the verbose output. So I knew the command lines of execution. But it didn't work for Ninja, it didn't work for other generators. Fortunately, in CMake 3.14, we got the -v or -- verbose flag that you can just pass to build here, and no matter what generator it is, it will try to provide verbose output. So it works again for Makefile, for Ninja, and you can easily make it verbose with this command, again without knowing the tool used below. Or you can put it, for example, in your IDE. I'm setting this often in Visual Studio Code, the IDE of my choice, as the option for building to find out how actually Visual Studio is building my code. Talking about IDEs. In CMake 3.14, we got file-based API. It improved integration with IDEs. It's supported by every major IDE and provides better performance. We don't need to run CMake server mode anymore, and we don't have to parse files generated by CMake as other IDEs were doing. It uses also less memory thanks to this. But what's one of the most important things that I think is that it allows you to use any generator with any IDE. Until then, for example, in CLion, you had to use Makefile-like generator because CLion, for example, was parsing the scripts and it didn't know about the syntax of Ninja or other generators. Now, you can use any generator in your IDE and it will work because the communication is done with different protocol, with file-based API rather than just with files being generated by the generator. So again, I just set Ninja multi-config as my default generator in Visual Studio Code, and it works great. Okay. I think this is the last thing I want to mention. Before CMake 3.15, we have to always force config if you want to find a package based on config mode of find package, because find package has two overloads, nearly like in C++. We have overload for modules and overload for configurations, for config files. And we select the other overload with this config keyword here. And this one will basically work differently. It will, if you don't have config, the CMake will use find scripts, and those find scripts prefer system installed packages. Config option prefers user-specified packages with configuration scripts. And it's always bothered me that the default is wrong, nearly like in C++, right? Basically, CMake prefers by default one that installs in the operating system, even though you provided newer one or different one through the package manager or by hand. With CMake 3.14, we are able to specify CMake find package prefer config. And then if you just spell find package gtest required, it will find gtest provided by your package manager rather than the one installed in your Ubuntu system, the old one. So this is a great option. You don't have to specify this in the project because, for example, Conan sets it by itself with the latest releases. So every time you use Conan, it forces gtest to be used with the config mode, so the one that Conan actually provided. Yeah, I have a comment from Jeff Garland that he's even not sure if they ever made find boost to work correctly because it's a nightmare. Yeah, boost is, is a beast, and it's not to actually make it work easily. I was a bit involved with adding boost to Conan, and yeah, it's not easy. Okay. So this is all about the latest features I really like the most. Of course, there are much more features there. Features that maybe I don't use, but really important ones, like support for CUDA and other languages and many other things that are great. I just mentioned those that actually I personally use and I personally enjoy. So please go there, see what has changed, and maybe you'll find something more that basically will make you happy. The next thing I would like to talk with you is to provide the refresh update on modern project structure. I provided some highlight of it 3 years ago, but after that I had many discussions and many questions from the people and actually requests to provide more detailed design to the community. I think that even Jeff or someone on Monday's keynote asked about this subject exactly. It's how we should structure our code in repositories in order to benefit the most from packages. First, let's talk about the problem introduced by add subdirectory. For example, we have library A that uses privately gtest for unit testing and basically uses public dependency here on boost. It exposes boost 166 in its interfaces. And then we have library B that has different assumptions, right? It internally uses OpenSSL, doesn't expose interfaces, but it uses it. It exposes boost 157 and also uses gtest but a different version here. And of course, there will be some application that takes library A and library B, and additionally it takes gtest from the latest version, another OpenSSL version. And as you remember, lib A and lib B provide different boost headers from different versions, right? This cannot work correctly with add subdirectory. And actually, no one will probably prevent you from doing this. You will be happy if you will get a compile time error or a linking error, but sometimes it may just compile and just don't work correctly. And you are puzzling what happens and what's wrong. So handling dependencies as subdirectories doesn't scale. That's why I don't like monorepo approach. That's why monorepo approach doesn't work correctly with CMake. If you start to create problems for you doing monorepos, basically I always say, if you didn't have problems, you invented monorepos. And then when you invented monorepos, you have to invent a build system like Bazel to work with monorepos correctly. Because things like CMake will not work correctly for you. So this doesn't scale. But it's not only a problem of collisions of different versions. Even if there are no version conflicts, add subdirectory still doesn't scale. This is caused by the fact that imported CMake targets have a global scope. Not imported CMake targets, so the ones that you define, not import. They have a global scope. So if you combine multiple projects into a single build via add subdirectory, creating a monorepo, you may end up with name collisions. Some targets will be duplicated. For example, if you provide the same dependency like gtest twice. So you have information then that the gtest main is defined twice in your tree. And you will have to somehow if-def, right? Header guard to have one definition rule only in CMake. Also, it happens that even if you have different projects, some names are really common, like core, utils, unit tests, and you may have different unrelated projects that chose to use the same name for the target. And CMake requires all of the global targets to be unique. From my experience is that the more projects you have in your company, the more probability is that your names will collide. Because different companies tend to provide different names. While we use underscore, another one we use hyphen here, right, as a separator. But the more you do in the same company with the same naming conventions, the more probability that at some point your targets will collide, creating this monorepo approach. If you want to go with monorepo, I cannot prevent you from doing this. A good solution is to always prefix every target, especially short one, with the project name. Then you provide unique global targets, because each project name will provide different core, different unit tests, and so on. And then you provide an alias that basically provides you the project name, library name, and aliases this one. And basically it's preferred to use aliases for linking later on, rather than the target's names by themselves. So even though you should not use @subdirectory to create monorepos, someone else may decide to use your library in this way. So as a library writer, you should prepare your library for such use cases. So please add those to publicly exported targets from your library. However, if you will provide those prefixes to your targets in the libraries, sooner or later you will have a problem that those prefixes will end up in your library file names, right? It will be called myprojcore.a, for example, rather than core.a, and you don't want to have it. Then it's required to set a target property export name for this target to say this is my file name, so it will be core8 or libcore8, depending on the operating system for which you'll be building this. And then also you provide namespace during installation, so this core will end up as myproj::core, so exactly the same as an alias provided here. What about private targets? Not exported ones. Unit test, usage examples, maybe some documentation generator, or maybe some sanitizers being run. Those should not be exported at all to your dependers if they will include you with @subdirectory. They pollute CMake project with external targets. If you, for example, go to CMake view in Visual Studio or Visual Studio Code or any other, you will see thousands of different targets. And you will see a lot of unit tests from gtest maybe or other libraries. And you don't care about those to see in your CMake view of your project, right? Those should not be exposed to external users. Also, if you run a C-test, print all of the tests, you know, like I don't know, minus list or whatever, you will get all of the unit tests for every dependency together with yours. And it's sometimes even hard to run only your unit test because you have to put some filters, some regular expressions, just to be able to filter your test from the crowd. And as we know already, targets with the same names may collide. So the less targets you expose to dependers, the better you are, and the less possibility for collision. That's why I provided this modern project structure and to address this solution. It's basically designed to help separate project development workflow from its usage by dependers. So developers of the project do one thing and users do another thing. So users, the dependers, should not be forced to include not exported targets, and also should not be affected by your development environment, compilation warning flags, sanitizers, or maybe other things that you use for development, right? I don't want some strange library to force me to use some compilation flags they use, like pedantic extra. Of course, this is a good solution, good thing to do, but I don't want them to change my settings. If I decide to not use pedantic, I don't want some other library to set it up for me. But this is what's typically done in the CMake as the first thing. Set CXX flags to WAll, WError, WPedantic, WExtra, and whatsoever. And then it's being overwritten for everything in your file tree. I will show you the solution I invented on next slide. I don't say it's the best solution or the solution for the problem. It's just the one that I used for me and it works for me. Of course, you may find some other things to work for you, and you are welcome to experiment with that. But I will show you something that works for me, and it proved through many years to help here. So what I do, this is the executable. I have here two different structures. One will be for executable, another one will be for library. Library is a bit more complicated. So for executable, we have sources, tests, and CMake list txt and Conan file. Conan file basically lists project dependencies and their configuration, and provides the build system generator data. CMake list is an entry point for development. You open it with your IDE, for example, or do CMake in your CI, CMake configuration in your CI from command line. It enables all developer-specific features, compilation warnings, unit tests, building docs, whatever, everything that should be provided by default for developers to provide correct build in CI and in their daily flow. And it's a simple just wrapper. Besides setting those flags and development environment, is just a simple wrapper including source and test, because they have their own CMake files there. Source has a library, CMake list, main, and tests. Here are tests, right? Source lib CMake list txt here defines library target. It provides most of the implementation of your project. Of course, there may be some subcomponents, more CMake lists involved here, but this one creates the library of your project. Even if it's executable, it should have a library somewhere. And this then is being used as an input for the executable to link with, and for unit tests to link with in order to test the code. The other CMake lists in source directory is the standalone CMake file, but by standalone I mean that it can be called from the command line by the user. It's entry point for customers. If I'm a customer, I want this executable, and I don't care about development flags, I don't want to write unit tests, create documentation or whatever, I'm going to this file and do configuration and building step directly on this file. It doesn't affect any of the development environment that I chose to use. The only purpose of this text, of this file, is to define the final executable. It adds the lib subdirectory with add subdirectory, and as I said, it doesn't change any development environment stuff. It shouldn't. The last one is the test directory. It's included by the wrapping one. It's not a standalone, so you should not call it directly. It defines unit test executable and links with the source lib CMake list, the target defined in this file. The next one is the library. Library is a bit bigger, as you can see. We have examples, we have test package here, and we have Conan file Python rather than txt. And with Python, we can provide more logic. We can provide information how to build, package, and reuse our library with Conan. The CMake list is similar to the previous one, it's the entry point for development. It enables compilation warnings, unit tests, usage examples, building docs. It's a wrapper over source, example, and test directories. Not test package. Test package is separate here. Only test. In source, it is similar. It's a standalone CMake file to be used by customers. We have several components here. Those components are being added with add subdirectory. And as I said, this doesn't change and development environments, right? Users should not be affected by your development settings. So if you are a user, you just want the library to compile, to build, you go here and directly interact with this file rather than the wrapping file one level above. And then you have components. Basically, they implement specific features of your library. Thanks to the fact that they are in separate directories, it's really easy to enable and disable them based on some project configuration options. If you don't need them, you just don't do add subdirectory on them. It's really simple to disable them. And one more important part that I often basically see done wrong. Every library has private and public interface. Private interface I tend to provide directly with the code, right? This header is a private one, provided directly with the CPP file. It is not exposed as an interface of the library. In the include directory, I only put the public ones. And then when I'm doing installation step, I just copy-paste this public header to the installation package. And those private ones are not needed anymore because they are part of my binary. This simplifies a lot installation step. This simplifies a lot high-level architecture on how to basically provide interfaces and not make them confusing. Because at some point when I go as a consultant to some companies, I ask them, what's your is this a public interface? They say, we don't know. We have to check in our installation process if this file is exposed to the user or not. If you don't know if your header file is public or not, then it's a problem, right? When you use it, when you include it, how you write it. I often even have a different namespace for those internal header files, like my project : detail, just to make sure I'm not exposing those in the public interfaces at all, or not including them, those headers in my public interfaces. Okay, and the last one is this test package. As you are doing the library, every library should have an installation step, either with CMake or with Conan. And you should have tests to verify if your installation step actually succeeded. It's another standalone file. It's not included with any other wrapper here. You are just going to this one during testing, during CI, to find out if your CMake or Conan installation basically was correct. So you can basically link to it, to the installed package. You can find headers, and everything compiles correctly. So we have here two use cases. If you're a project developer, you go to top CMake list.txt. You either open it in the IDE or use it from the command line, right? You provide build, tests, and installation step, maybe with stripping the binaries. If you are a user, depender of this dependency, you go to source CMake list.txt. You don't open this in IDE because you don't care. You don't want to see this all code in the IDE. You just want to have this library or this executable, right? So you go to source CMake list, do everything exactly the same. Maybe besides testing, because you don't have access to test anymore in this case, and maybe you are actually doing this because you don't care about development environment. But if you care, of course, you can use the left column flow and have access to all of the development things if you want to be extra safe that everything is okay before installing. And while talking about installing, I would say that keeping dependencies as subdirectories in a project file is irrational. And I mean here both sources in this SRC with, I don't know, a git submodules or maybe copy-paste, external directory or whatever, as well as downloading this with fetch content or add external project during the configuration phase or build phase and stored in the binary of your project, binary tree. Notice that it has to be re-downloaded each time for every project. If you have 2, 3, 4 branches of the same project, you have to download it for every case. If you have 2 different projects using Boost, or 5 different projects using Boost, everyone will have Boost. And right now you are out of your SSD file drive, right? Because multiple copies of the same sources take a lot of disk space. Have to be recompiled with every project. So I have Boost on 5 different projects and I have to recompile it with 5 different projects. And it takes a lot of time. And it takes a lot of space. I mean the binaries, not only sources. And again, those are added as subdirectories in most cases. So they pollute our CMake projects with external targets, CTest with external unit tests, and again we may have name collisions between projects. That's why we don't want to keep projects as subdirectories. We want to install them in some common staging area. But in this case, we need separate directories for every option that may affect the API of the project. And things that may provide different API are build types, compilers. If you run your project on different compilers, and I do, you have to specify different directories for each compiler separately. C++ standard library version also provides different API. Even C++ standard version can provide different API. If you don't change your sources, don't provide any preprocessor branches, then you're fine. This shouldn't change API. But if you will say that if I have C+17, I'm using stud variant rather than some open source variant, then you have different API based on the standard version selected by the compiler. And basically some preprocessor flags also change API, and many others. So actually you should provide installation tree that will have different directory for every different combination from all of those options. And as you can see, it really stops to scale at some point. You will have hundreds of different trees, different directories, different branches, and you will have to install to correct location and then find it with find package from the correct location. Unless, of course, this is a header-only library. And in such case, you don't care. One copy is enough. Or maybe it is not affected with C++ standard version. Then you may have less copies. But as a user, you never know. You don't analyze the sources of the project as well. And even if you analyze it right now, it may change in a quarter. And you will be again having some API issues. So in most cases, I asked my students during trainings to provide debug release for each compiler as separate directories and install them manually. And after that, they are begging me to allow them to use package managers. Because installation process is cumbersome, space and time wasting. And most packages, for example, will even not allow you to install several versions of the same package. I did mention this on the previous slide, right? If you want to have 2 different Boost versions or 2 different GTest versions, you make CMake install. They will try to install to the same directory, not different ones. And it may be an issue. And what if your dependency doesn't use CMake at all? Then CMake fetch content will not work. Right? Add subdirectory will not work. You have to find other ways then to use it. And this is why we should just stay with package managers. And I was actually a bit surprised, but it's also what we've heard on our keynote on Monday. Right? we've heard that CMake can go only so far with external project and fetch content. If you really want to do a project on a big scale, you should go for package managers like Conan, VC Package, Spack, or others. I don't want to go in the holy war here. Which package manager is better, Conan or VC Package? They both have their use cases, they both are great, but I prefer Conan for large projects, for enterprises, for commercial usage. And that's why I'm going to talk about Conan right now. First of all, I want to share with feedback from my customer about Conan. I suggested Conan to them. I even didn't do a training for them about Conan. I just said, this is a great documentation, go and try it. After a month, I asked the customer how it went. And this is the answer. Conan just works. You don't hear that often in the C++ ecosystem, right? And I was really happy that it proved so good, because I also have such great experience with this tool. First of all, I always say that Conan client interface is really simple and intuitive to use. If you are actually have any doubts regarding it, you can find a great documentation right away with -h, or go to docs.conan.io. Documentation of this project is simply great. I think that there will be never any book about Conan, because the default documentation is so great that no one will probably ever try to write a book and sell it for money if there is a free documentation of a great quality there. There are also free trainings. If you want to go, you can go to JFrog Academy, find trainings on Conan, and you'll find 3 different trainings: Introduction to Conan, Conan Essentials, and Conan Advanced. Really good ones for free, and you can learn details right away. One of the benefits of Conan is that it abstracts away build systems. Typically, as a user, wanting to use or creating your app application that depends on maybe Foley, Boost, OpenSSL, Appsay, each of them is using different build system by itself. You have to learn them in order to know how to work with them, how to compile stuff with them, right? And then to find out how to import them to your CMake build system of choice for your application, right? It's not trivial. It may discourage many developers from trying working with C++ at all. When you have a package manager like Conan, then you're interfacing mostly with Conan. Conan can basically download, install, compile, build, install all of the dependencies. This is the Conan, the one that interfaces with all of those different tools. You don't have to learn them. And even Conan can build your project if you prefer. But if not, you can work with CMake, the build system of your choice, to build it. So how to start with Conan? First, you have to install it. Second, you have to set a development profile. Optionally, you can add some custom repositories, because Conan is a distributed build system, distributed package manager. Like Git is a distributed repository for version control system. Then you should create a Conan file for your project. And in this Conan file, you have to provide dependencies for your project. So installation. Just do pip install Conan with dash big U. You will have also an upgrade option to always stay on top. And that's all. Conan is installed and works correctly for you on every platform that supports Python. During the first execution, Conan will initialize its configuration. All of the configuration by default goes to the home directory .conan, and then you can find all of the files with the configuration of the project. Among others, a default profile will be created. It's created based on auto-detection system, and it will be located in Conan profiles default. It's just a test file. So you can go with your editor of choice and modify, update it, or view it. Also, you can use a command line to show it. For example, it generated something like this for me. I'm using GCC version 10 on Linux. Actually, it's Ubuntu in my case, 64 bits. By default, build type will be release. And this is actually maybe an issue for you. That's why I'm going to talk about it. Because of backward compatibility reasons, until Conan 2.0 that is coming soon, this one is selected for every GCC. It provides the API of strings before GCC 5.0, so this copy and write strings rather than the one mandated by C++11 standard. So in most cases, the first thing you have to do after having the default profile, you have to change it to use C++11 version of it. As I said, this is maintained for the backward compatibility reasons, but with Conan 2.0, there will be a breaking change that will fix it, and you will end up with a correct library by default right away. In order to fix it, you can either open this in an editor and change it, or use a common instruction, command profile update, and you provide setting compiler libc++, right? Because it's setting compiler libc++, and specify libstud C++11 for the profile named default. As I said, Conan 2.0 will be selecting this as a default one for GCC greater equals 5.0. Alternatively, if you are using Clang, you may want to specify this libc++ to libc++ library here, right? Because you may want to use LLVM-based standard library rather than the GCC one. Another thing that you may add to your profile, you may add CppSTD to a standard of your choice if you want to override the default provided by the compiler, because by default the one specified by the compiler as a default will be used. If you want to use a different one, you may force it with CppSTD setting 20 or 17 for an older compiler, if you prefer. Alternatively, if you don't want to append your profile, you can always, for every installation, you can just specify this in the command line, settings compiler CppSTD equals 20, and then it will be appended to your profile, so you don't have to change your profile with those things. You may always add some stuff or modify some stuff in the profile from the command line. And this is the default one. But the default one is always or often not enough as a developer. This is even not all of the list of the profiles I have right now on my platform. If you do Conan profile list, you will find out that I have Clang 11, 12 with Leaf standard C++11, Clang 13, a default profile, GCC 7, 8, 9, and 10 installed on my file system and working correctly. And often for different projects, I try it on every single compiler before I commit. And it works with every dependencies right away. I don't have to think where I installed basically compiled with Clang 12 or where is the one for GCC 7. It's always found correctly. Profiles are just text files without an extension, so if you actually list the contents of this directory, you will get exactly the same answer. These are the profiles for release builds. If you want to have default ones, debug ones, then you can of course create more files, or you can override it from command line. And this is actually what I do. I don't create debug profiles. If I want to have a debug build, I just specify it from command line, and then the settings is overridden from the profile with the one provided in command line. If you want to handle more than one GCC, more than one Clang in your file system, you can specify those with environmental variables here. If you want GCC 10, you may specify this is how I find GCC 10. For Clang, you may find Clang and specify libc++ here. For Visual Studio, This is how you specify it. You may even use some min.gw, for example, from MSVC2. And notice that this one will be downloaded during Conan install stage. So you don't have to have this tool even installed on your file system. It will be downloaded during installation and then used for compilation. You can also distribute profile files with your project source files. And then it's useful to just amend stuff. For example, this is something that takes the default profile from the system and provides cross-compilation for this profile for ARM version 7. And then you can specify just, instead of using profile from the default directory, you can specify exact path to one in your project directory. And then this profile will be used together with the default as an override. You can also override some settings from specific packages or some environmental variables for specific packages in your profiles if needed. Profiles can be composed. You may, for example, specify some generic profile for Windows and then provide profile that only overrides Visual Studio flags to specific version. And with this you will have release. With this you will have even more information, because you will have debug here. And then you can work with this, and it works both for install and create commands. So for every command that basically takes a profile. There is a question from Jeff. If you include a profile, can you then reset things in the default profile? I don't know what you mean by reset. You can override them. But in terms of reset, I'm actually not sure. I don't know, for example, if I can reset this added CPP standard flag. It's not there by default. If I added here the default one, I'm not sure if I can reset it from the command line. But I'm not sure if you are asking about this. But you can always override stuff from default with other stuff from the command line and other options. Do the profile stacks? Another question from Stanisław. Yes, as I said on this graph actually, right? You have profile for Windows, profile for Visual Studio, and even debug flag overridden. And this just stacks and composes correctly, right? So this one will basically, you can specify more of them and override the options from the previous one with the next one. As you can find out, there may be many profiles to set. I have at least 5 or 7 on every platform. And it may be hard to manage to have them consistent for your corporation, for example, or your project. That's why with Conan, you can easily share the configuration with other developers. And it's supported natively by Conan through the API. You just specify Conan config install, and you can provide a Git repository, and the configuration from this repository will be installed. Sorry, I thought I muted my phone. It's muted right now. Sorry for that. So this command basically obtains the configuration and installs it on the local file system. And you may provide either one specific file or entire configuration. It's up to you what you want to share. You don't have to share everything. You may share only specific files. And it can be downloaded from a local or remote zip file, from the local directory, or from the Git repository, as on the example above. And only, of course, the files that are shared are being replaced The ones that are not shared are the ones that are preserved on the file system. Okay. So now we have the command installed and we created profiles to work with. Now we have to get packages. By default, Conan Center is configured in every Conan, and Conan Center is a central public repository for open source packages. It's moderated and maintained by the Conan team, and there are contributions by the community. So everyone actually can submit some package to this repository, but it will be verified. It will go through CI to verify if it works correctly with every configuration, and also will be code reviewed by the Conan team to find out if the recipe is correct. It already contains hundreds of popular libraries and applications. You can find all of the recipes for those packages in the Conan Center index. This is the GitHub repository. It has integrated CI. So basically, if you submit something as a PR, it will be tested first before anyone actually will look into your commit. Conan Center looks as follows. If you go to Conan.io, there will be Center. And with search, you can find any package or just browse them here. It's really convenient to work with. As you can see, there are more than 500,000 different versions being indexed right now in the library, in the database. But this is a central repository, but Conan, as I said, is a decentralized one, right? So you may use, of course, the Conan Center if you're working on open source, but actually you may even decide to remove it if you're working for a corporation and you don't want to interact with the internet. You can create custom remotes, add more than one if needed. And those may be useful to create live head public packages. So basically you can provide releases often. So every user will be able to live at head of your package rather than having some gradual releases on Conan Center. Or maybe you want to provide some packages that are not meant for a larger audience, but are being used, like in my case, for example, for my trainings, I share some specific exercises through Conan with my students, but they should not belong to Conan Center because they are not for a large audience. Basically, you don't have interest in those. Or maybe you have some non-standard configurations that are not supported by Conan Center. For example, Conan Center does not compile binaries for C+20 right now. And I do for my library. And I want my CI to be fast. So I uploaded all of the artifacts for open source packages that are hosted on Conan Center, but those artifacts are compiled for configurations not supported by Conan Center. And thanks to this, my CI is much faster because they are being downloaded from my repository rather than being built from scratch every time with every CI step. Or you may want to have private packages, right? Owned by your corporation. Then you may set up private repository in your private network and use with private packages. For each of those cases here, the answer is JFrog Artifactory. It's self-managed, so you are responsible for managing it. It may be either on cloud or on-premise. And the easiest way to start with it is JFrog Artifactory Community Edition for C++, which actually is for free. So you can take a free server, install it, and work with it easily in your corporation. If you want to set up one in the internet with the public packages you provide, you may go for JFrog Cloud, and they provide the platform for free with quota of 2 GB, if I'm not wrong, and you can share the libraries there. The only inconvenience here is that they provide you mails, and may basically, I think that they may remove your repository if there is no activity for 2 or 3 weeks on it. Actually, this is a bit inconvenient because with bin tray, previously we didn't have to provide such traffic on the server before. Right now we have to use it in order to keep it. I hope it will change at some point because we had some escalations lately, but for now this is true. So if you don't use it, you will have emails asking you to either provide some actions or it will be removed at some point. So as I said, Conan is a distributed package manager. So with Conan remote list, you may specify different servers you work with. As you can see, I'm having my private cloud JFrog account Artifactory as a first one, the most important one. Then I have one for my training company. Then I have Conan Center, the default one. And then I have the linear algebra I'm using as a dependency for my MP units project. Actually, this link here for Conan Center is a new one. It still has a beta status, but this is the one that will be used in the future because the previous one, Conan bintray.com, basically will stop working at some point because bintray is end of life with beginning of May. So officially, all bintray accounts were closed and all services stopped. It still works for Conan, but at some point this link will change. So you also have to update this in your Conan configuration. And Conan file. As I said, in order to start getting dependencies with Conan, you have to create a Conan file. Conan file provides dependencies like my library from my custom repository and boost from the Conan Center. You may specify options, saying, for example, that I'm interested only in header-only version of boost. And you may specify generators. I chose to use CMake, and currently the best generators for CMakes are those. Those are experimental, and those are meant to be the default ones in Conan 2.0. There may something change. Maybe it will be, for example, like merge to one, because I've heard that maybe something like CMake Gen or whatever as a wrapper on those two. But still, those are the best solution right now to work with. And actually, the dependencies are bigger than the ones specified here, right? I'm working directly with MP units and with boost, but MP units, for example, depends on FMT and GSL Lite. I don't have to specify this. It transitively is propagated from those packages. I don't have to provide them in this file by myself. So let's talk a bit about this line here. This is called Conan recipe reference. It has a form of string, and it is an identifier of the Conan package in the Artifactory. One recipe reference can represent any number of separate physical binaries, right? You provide only the product you want to use, not a binary for GCC 10 with C++20 standard, for example. So the singling identifier, being able to represent many different binaries, is one of the Conan major innovations. And it has different forms. A short form, where you have only package name and package version. Package version can be of any string, but in most cases it is semver. And this short version is typically being used by Conan Center packages. You should not use them for your custom builds. And also it's worth noting that if you want to use it from the command line, you often have to specify this ampersand sign, like this one, after this, because otherwise it's treated as a system path and doesn't work correctly. I hope it will be fixed in Conan 2.0, but for now you have to specify this in this way, saying that there is no postfix that is a default package. And postfix is a part of the normal reference, where you can specify an owner and a channel. As I said, those can be omitted for Conan Center packages, but for your own you should provide them. Owner basically specifies who is the owner of the package version, who is maintaining it, and it allows different users to specify the same package with some custom modifications. You can provide some patches, some modifications to, for example, boost and distribute them as your own owner. And channel specifies a, let's say, branch on or development branch on this development. Let's say stuff. In most cases, basically, it's denoting the maturity of the package. It's either stable or testing, but you can use any string here. So here you provide you, or company name, or maybe project name. And here you provide, for example, stability or other identifier that you prefer to use it to disambiguate those packages. And there is also a full reference when you can provide package ID and recipe revision and package revision. And this is even more specific. This is even more detailed. And allows you to refer exactly to specific package in the Artifactory. Even if you overwrite several packages with the same version, Artifactory will store them with different identifiers, and you'll be able to refer to them to have reproducibility of your builds. Ninja multi-config and CMake deps work great together. This is what you have to do as a workflow. You create a build directory. In the build directory, you call Conan install with your profile, Conan install with your profile, and debug build. If you want to have two possibilities for building, then you make a configuration step. And in the configuration step, you have to provide toolchain generated by a Conan toolchain generator. So you provide Conan toolchain CMake, and then you build and build debug, and it just works. This part profile can be skipped if you're using the default one. Then you don't have to specify it. Notice that you don't have to specify CMake install prefix anymore, because Conan is the one responsible for knowing where the dependencies are. You don't have to provide this information anymore. All of this will be embedded in this Conan toolchain and dependency files generated by Conan. Talking about the installation step. By default, Conan will always look for a pre-built binary and will fail if it's not found. It does not silently build from sources. It helps you to basically to maintain a fast CI pipeline. Build once, use forever. And it also makes you sure that you're using exactly the same binary artifacts for all dependents. So what I do, I always build the dependency once for my configuration, upload to Artifactory, and then I'm just reusing this one. So by default, nothing is being built. You will have an error if something is not pre-built for you. But you can, of course, build it if you want. If you just provide -b option, it will force rebuilding of every package. Never is the default one. It will never build the package, even if it doesn't exist. Missing will build only packages that are missing. Outdated, so this will be missing and outdated packages. There's also cascade option. And you can provide a pattern of things that should be built. And from the latest version, with the exclamation mark, you can exclude some things from the build. All package-related data lands in the Conan local cache. It's typically stored in the Conan data directory, but you can specify a different one with Conan user home variable. Notice that Conan is the one responsible for housekeeping here. You don't have exactly right now to create this structure of different compilers, different configurations, different standard versions that we mentioned in CMake, that you have to maintain manually. Right now, Conan is responsible for this. It creates different hash for every configuration and stores them separately so they will never collide. And Conan always know where the package built for specific configuration is and provides it directly to CMake without any issues. And Conan local cache helps in sharing the same dependencies between different projects, repositories on the same PC, or even can be provided as a global one for every user on your server. Generators. The most important generators are CMake toolchain, the one that generates the toolchain file, and it helps to achieve exactly the same build, no matter if you are building with Conan or with CMake directly. It generates Conan toolchain CMake file, Conan build JSON with information, for example, about the generator that was used, that should be used with this file. Or if you're using MSVC compilers, you will have a Conan VC vars bat that allows you to initialize the environment for the specified Visual Studio compiler. Another Conan generator is CMake deps. It's a multi-configuration generator. It generates one config per dependency. So it generates all of those config files for you. So if you are actually lazy with CMake, you don't have to generate them anymore. Conan will basically create them for you. And will also allow you to use packages that, for example, don't use CMake at all, or do not provide installation support at all. I've seen a lot of packages, a lot of libraries that do not provide installation step at all in CMake. Or maybe if they provide those, they are broken, they are wrong, they are incorrect. So you should not use them. It's encouraged to depend on the one generated by Conan, not the one provided with the project. The one provided by Conan should be correct and work correctly. There are other generators too. There is deploy that helps you to basically deploy your dependencies to one directory. With install folder, you can basically specify which directory should be used as a target for deploying stuff from the local cache. There's JSON that provides all of the information about dependencies in a JSON file, and it's being mostly useful for custom integrations. Besides having Conan text file, you may have Conan Python file. They have really similar contents. Additional stuff here is name that you have to provide, and settings, for which settings the hash will be created for your library. But you provide the same requirements, the same default options, and the same generators here. But you can provide more with Conan file Python. For example, you can import CMake helper and create a build method here that basically will create configure and build step for you. And with this, and everything you have to do to build your project is just Conan install and Conan build. You don't have to play with CMake, you don't have to play with Ninja, Visual Studio, whatever. It's just those two steps and you are done. If you want to start a new library, then you may call this option here, this command, Conan new. This is a template used for version 2 CMake, so it will be default for Conan 2.0, and provide the project name. It will generate a template for you with Conan file Python, some sources with CMake, CPP, header file, and test package with CMake, Conan file Python, and example. I'll just go quickly through those because we are nearly out of time, so you can generate them by yourself and see how they look. There are a bunch of methods like config options, generate, build, package, package info. So these are the steps done by the Conan during packaging. And test package is the one that is being used just to test if your package works correctly. It has only build and test methods here. By default, Conan creates a unique package identifier for every unique configuration, as we said already. It is provided for settings, options, and requirements of your package. Each unique package identifier is assumed to specify a different ABI of the same package, so it should be stored in a different directory on the file system. Right? Either it's a local cache or Artifactory. But for some cases, you may specify that some options doesn't affect ABI, or some settings doesn't affect ABI, and with this you can use package ID method. You can, for example, specify that my package doesn't build differently for different standard of the versions. ABI is the same. Or option build docs doesn't influence ABI of the package, right? So it should not. It should not create different directories for the option when you're actually building docs or not building docs. If you're providing header-only library, there is a shortcut for it. You provide only this one, and this is already known as a header-only. It has only one copy, one instance in an entire cache for each configuration. Every configuration will use exactly the same instance, so it's not copied everywhere. So with this, user does not have to guess anymore how many variants of those to keep in your file system, like it was the case in CMake. Now it is done by package manager. A new feature are also components, but we are nearly out of time, or actually out of time already, so I will try to just be brief here. Sometimes we need more than one library, or more than one component in the library, and those sometimes depend on each other. With package info, you can specify those components. Like for OpenSSL, you can specify crypto and SSL, specify the dependencies, different header files, different maybe preprocessor defines if needed, and those will be provided as separate targets, like with CMake configuration files. Unfortunately, this duplicates CMake install target data. CMake already knows it, and you have to provide it once again in Python for Conan. I know that's a problem. I hope that will be solved at some point, that, for example, CMake will be able to generate some files that Conan will just reuse, rather than being forced to duplicate the effort and specify it twice. If you want to learn how to write recipes, go to Conan Center Index. You will find the recipes of all of the packages there. You will learn a lot there. Conan 2.0 is coming. As you can see, there is still a lot to complete here, but it will come soon. I think it will be around late vacations period, I think, but I may be wrong. I'm not the developer. And it will provide new stuff that basically will make it even better and will fix some defaults that were wrong, like setting the different libc++ version, for example. There is a Conan compatibility mode flag that you can use to verify if your recipe is future compliant. And this is the list of the most important changes, but I will not go through them because we are out of time. Do you have any other questions? I don't see them right now in Q&A, and we are out of time. So basically, if you have any questions, please find me on Discord, or I will maybe go to Gather Town after this, and you can find me there, and we can talk about the details. And I'm really happy to help you with this. So thank you very much. Sorry for being late 2 minutes, and see you next time. Take care.